fine if you end up with a bunch of decimals out there. Do the second one, 27.5, it's 44% dry matter, you get 62.5. The third one, 22 pounds, it's 56.5 dry matter, you get 38.9. Now we'll just kind of go down the list. They're all, the math's the same if you can do the first three. So we go 31.6, 24.4, 18.3, and 78.6. Okay? And so what you should notice here is really dry forages. Okay? You don't have much difference between your dry matter and as-fed intake. What that cow's actually eating versus what she's eating on a dry basis. Your really wet forages, so silage is our wettest one here, it's about 2/3 moisture. She's eating a lot of volume of feed, almost 80 pounds of feed to get that 27.5 pounds of dry matter intake. So very similar with a cow on wheat pasture. She may eat 100 pounds of as-is feed, but it's mostly water. And if you walk behind a cow on wheat pasture, you understand how that works. Okay? So it comes out mostly water too. Some of that's water content, some of it's really high in protein. Both of those are going to lead to a really loose stool, which you know if you've been around cattle on wheat pasture. Okay? So we determined our quality. We looked up our intake guide. We got our dry matter intake. We divided by our dry matter. We got our as-fed intake. That's got us all the way through that first page. Okay? We flip over to the next page, part 6. Again, we've done most of this math for you, but a lot of what we do this semester is we'll look at a ration or a supplement, and we're typically trying to find the cheapest source of nutrient, okay? So anytime if I ask you, how do you decide what you're going to feed, whether it's calcium, protein, whatever, assuming it's all similar in bioavailability, you're going to feed the cheapest source of that nutrient. Oftentimes, that's not the cheapest feed, okay? So my classic example is you can go down to Stillwater Mill today, you can buy a 14% cube, you can buy a 20% cube, you can buy a 38% cube, and you can buy like their distiller cube, probably like a 28% cube, okay? Which one's the cheapest? The 14 is the cheapest, and then the 20, and then the 28 and 38 are similar, but they're different kind of products, whatever. Generally, the lower protein it is, the cheaper the cube is. Somebody that's not educated is going to go buy the cheapest cube, okay? But if I'm concerned with protein supplementation, 9.5 times out of 10, the 20s and the 14s are going to cost me more per unit of protein than the 38s. Because if I'm just supplementing protein, I can feed about half as much 38% feed as I can at 20, or even less than I can at 14. If I'm looking for an energy cube, an energy supplement, then yeah, certainly the 14s or 20s are better options. They're cheaper sources of energy. But on a protein basis, they're going to be more expensive. So a lot of people, you can go all day watch people buy 14s or 20s because they're cheap, and they're probably underfeeding their cows protein, or they're feeding way more of them than they need to be feeding. So that's kind of how we'll evaluate things. So you've got 2 examples there. You can look at the numbers. We won't put them on the board. So you've always got a price per unit weight with feed. A lot of times that's a cost per ton or cost per hundredweight. You buy sacks, cost per 50 pounds. But we always want to get our units to the same. So in this case, we're trying to get to price per pound. So if I've got a feed that is 9.25 100 pounds, that means it's a little over 9 cents, 9.25 cents per pound. If I'm trying to get it to a dry matter basis, it's 85% dry matter. That means it's about 11 cents per pound of dry matter. And then if I really want to supplement protein, if it's 12% protein, it costs me almost 91 cents per unit of protein. If I do that on a dry basis, if I do it on an as-fed basis, I should get the same number. So I can do dry matter to dry matter, I can do as-fed to as-fed. okay? This feed, I should be able to look at it and probably tell it's not a very good protein feed. That's an energy feed. If it's costing me 90 cents a pound of protein, that's pretty expensive, okay? If you look over at the next page, we've got Milo, okay? And we've got a price per bushel. And so if I want to decide if Milo's a good option for me as a supplement, I'm going to do this example for you to kind of show you that. First thing, this is a good point to talk about price. If I'm getting something to a price per pound and I'm dealing with pennies, 0.08, well, I'll let you catch up. I want you to carry 4 decimals on the price per pound, okay? I got ahead of Brittany because I wasn't paying attention. So I can stall. Watch me stall. So you guys are lucky, you know that? Because 2 of your TAs that presented at Southern Section won 1st and 2nd place in the graduate competition at Southern Section. So out of the whole South and Southeast U.S., you have the 2 top master's students TA in this class. Officially embarrassing. Brett and Courtney placed 1st and 2nd at the meeting we were at this weekend. Out of how many kids? 25 or 30 kids, so that was pretty cool. Makes me look good too. So if I can't teach, I can at least train graduate students. So, all right, stalled and embarrassed them, so mission accomplished. So if I look at these prices and I just round to 2 decimals, okay? So if I round to 8 cents, which most of the time we do that when we're talking about money, 0.075, 0.08, 0.084 are all 0.08, okay? So I want you on a pound basis to carry 4 decimals so you can tell me, because a lot of times we are a ½ cent difference, okay? If I've got 20 cows, does that make any difference? Probably not. If I have a 50,000 head feed yard, does that make difference? Yes, that's the difference in having a job or not having a job. If I'm in charge of layer houses or pig barns or whatever, that is a huge difference. Pennies add up to lots of money over 50 or 100,000 head, okay? So, calf in a feed yard's eating 25 pounds a day, it's a penny cheaper a pound, there's 50,000 of them in there. You start talking about hundreds of thousands of dollars or millions of dollars pretty quick, okay? So Milo, we've got a price per bushel. Milo, that means there's 56 pounds in a bushel. I don't expect you guys to memorize all those, I'll try and give them to you. Bushel is an old school way of referring to things that we still use, but it's based off a volume measure, what they used to call a bushel basket. So it's how much will fit in there. So the bigger, more dense something is, the more pounds it'll have per bushel. So what's the bushel weight of wheat? Somebody that knows? 60, okay? So corn and Milo, about 56 is kind of this gold standard. Wheat at 60 because, again, density, kernel size, those sort of things, because it's how much would fit in that volume. So if we take our price divided by how many pounds in a bushel, we get our price per pound. Again, would round to 8 cents, but we're going to report it to 4 decimals. If we want to get it on dry matter basis, we take that divided by our dry matter. So my price should go up. So we take our as-fed price, we get our dry matter price, and then if I want to find out if Milo is a good protein source or a good energy source, or protein feed or energy feed, I would divide by my percent protein and my percent energy. So if I take my price divided by my percent protein, I get about 86 cents a pound. If I do it for TDN, I get about 11 cents a pound. So my question to you guys then, and you'll need to know on your fee ID, is Milo a protein feed or an energy feed? Energy feed. It's much, much, much cheaper to supply a pound of energy or a pound of TDN than it is to supply a pound of protein using Milo. If you do that same calculation with soybean meal, you're going to get the exact opposite answer. So Your energy feeds, cheaper per unit of energy. Your protein feeds, cheaper per unit of protein. So milo would be an energy feed, certainly. Okay? So part E, we've got a group of 1,200 pound cows. They need an additional 1.4 pounds of crude protein, or they're 1.4 pounds of crude protein deficient. Your local store has some 20% breeder cubes that are 320 bucks a ton. So we take our desired amount of nutrient. In this case, we want 1.4 pounds of crude protein per head per day, divided by the percent nutrient in that feed or